Okay, welcome everyone. My name is Maximilian. I'm working for EclipseSource, and the topic of my talk today is EMF, JSON, and I. And when preparing the talk, I realized that maybe the title should have been EMF, JSON, and XML, because actually I would like to show you how to get from EMF to JSON and from EMF to XML in a very simple way. The scenario that is the context throughout this talk, at least my context for creating this talk, is the following. We have clients, desktop clients, browser clients, or mobile clients, and those clients need to talk to a server, and they need to send back and forth messages, maybe in protocols. It doesn't really matter which one, maybe JSON RPC, XML RPC, some RESTful API that communicates through HTTP, or even SOAP. And at some point, when you use those protocols, you will need to encode some data that you need to send back and forth. And sometimes that's simple data, like just a parameter as a string. But more often than not, it's more complicated structured data that needs to be sent along. And that can typically be done with JSON or with XML. And that's why I want to look into how do you do that in combination with EMF. As an example, if you build a RESTful API, for example, for retrieving visitors of the EclipseCon and retrieving their data, you would send a GET request on a URL that is a resource for one particular visitor with this ID 92813. And you would get a response that maybe describes the visitor in the following way, which is a JSON object with a couple of properties. I don't really care for this talk so much on what's on the client side, what kind of technology. That could be all kinds of different technologies that are somehow able to interpret that JSON or XML that you send. But somehow on the server side, I envision that this is a Java server that runs Java with EMF, so that you actually get into this scenario. You have an EMF model on the back end, and you want to send out some of those objects as JSON or XML. You could, of course, also use that on a client to create responses for a server. So the scenario is a little bit flexible, but that's the general setup that I would like to look at. Now, before we dive into actually converting stuff, just a quick recap. How many of you are familiar with EMF? Okay, so that should be a quick one. So I will always talk about E-objects. Those are the instances that the server has in memory. Those are instances that are basically Java objects. They represent a data object that you would like to serialize. So when they have been generated with EMF, the classes of those E-objects have been generated with EMF. They have getters and setters for the attributes. And the classes are based on an EMF Ecore. The generation of those classes has been done based on an EMF Ecore, which describes the structure of those data objects. And then I will also talk a little bit about XML and XML schema. So XML is a text document format. It is supposed to be human readable. More often than not, I don't find it that readable, but it is at least machine readable, and it's quite often used to send data. And there is a standard called XML schema that allows you to describe the structure of your XML documents. It is an XML document itself, as it usually is the case with those modeling, meta-modeling, bootstrapping things. And the real benefit of it is you can validate an XML document or an XML string against an XSD to see whether it conforms to that. So on the right-hand side, I have a small example. This is an XML schema that defines a complex type with the name user, and it has a sequence of tasks that are defined somewhere else, and then it has an attribute first name, last name, and email, which you can see here. and they all have strings and types that are strings in this case, and some of them are required. And below you see an instance that conforms to this schema. So I have a user with a first name attribute, last name attribute, okay, some other attributes that's a little bit inconsistent, and then a couple of tasks. And typically what you can do is when you have that XML schema on the client or on the server side, you can validate things that are sent along by the other party to see whether they're actually valid with regard to an XML schema. And then finally, JSON and JSON schema. So JSON, again, is a text document format, human readable, machine readable, often used to send data. Probably these days used more often than XML, especially if you have a mobile or a web-based client, probably because those technologies have better support for this format. And also for JSON, there is a schema language. It's called JSON schema. And again, it just describes the structure of the JSON documents that you send. And it is a JSON document itself. And on the right-hand side, I have an example again. So this is a schema that says that whatever you send there needs to have a first name property of type string, last name property of type string, and email. And below here is just a piece of JSON that is exactly that. So now to the actual topic of the talk. Let's start with EMF Ecore in the middle. So at some point you define an EMF Ecore, and basically I would see that on the model or schema level. That's defining how your data looks like. So I would like to separate that from an actual instance level where you instantiate whatever you have defined on the model and schema level. And if we look at EMF Ecore, that's basically E-objects. If it is a concrete Ecore model, if it is a user, then on the schema level we have the user class or the user E-class in Ecore terminology. And then on the instance level we get the E-object of type user. And when we look on the left-hand side, one of the use cases that we're going to look at is how do I just take that E-object and convert that to an XML and back again. So that would be useful if you have a REST API and you want to send out XML. You can store the E-object as XML, send out that string, retrieve something back, and maybe deserialize that again into an E-object graph. That XML is hopefully conforming to an XML schema. And there's also a way to synchronize that. So if you have an Ecore, you can create an XML schema out of that Ecore that just describes the very same thing, and vice versa. And then when we go onto the other side, we look at JSON. There is a way to take an E-object and serialize that into JSON, and then retrieve JSON and deserialize it back into an E-object. And hopefully that JSON will then correspond to a JSON schema. And with the tools that are available now, there is a way to convert an EMF Ecore into a JSON schema. However, I don't know about a way to convert a JSON schema back into an EMF Ecore. At least there's no tooling for that to my knowledge. So the question was, is JSON schema a standard? I'd say yes. Actually, I've even given talks about that. What puts people a little bit off JSON schema, that the standard is still in a draft state. But it is in a draft state since a long time. And people are deploying the draft state versions of JSON schema like everywhere. Google is deploying it to describe their APIs based on JSON schema draft version 5, I think. It is still very actively developed, while of course XML schema is pretty much done, right? There's not much movement going on there anymore. So I would say it is a standard. To answer your questions. Okay. So to my knowledge, there's no way back from JSON schema to Ecore, although it would be possible, of course, conceptually. There is some caveats that I would like to look into later. My plan for now is to first look into this arrow, so the number 1 arrow, to convert Ecore to XML Schema and back again. Then I will look into how to do that on the instance level, so to create XML from an E-object and back again. And then Ecore to JSON schema, and finally E-object to JSON. So let us look into the first scenario, that is how to convert an Ecore into an XML schema and vice versa. That's very well supported just by default functionality in EMF. What I have here is a modeling tools package, and it comes with everything installed that I need, so I didn't need to add anything else. And what I have here is an XSD, this one. It describes the Ecore model that I have. Parts of that are maybe something we can recognize from the slides. So we have a user here with a couple of attributes. And to create an Ecore out of that, I just create a new EMF project with some name. And then I can select to create that from an XML schema. And when I then browse the XML schema that I have here, I get an Ecore from that. And if we look into that Ecore, no surprise, there's, for example, a user class, and it has a first name attribute of type string, and so on. This has been built into EMF very early on, so this is super mature technology, and that has been used a lot. You can also do the same in the other direction, so you can export a JSON schema from your Ecore. If I am correct, it is here. Okay, for some reason I don't find it now. It should be. It's in the gen, so I was right in the gen model. Ah, here it is, yeah. I was blind before. So here you can get it, and you get an XML schema from that. And then you can export that. So that's pretty straightforward to do that. Common use cases are many people that start with EMF already have an XML schema, so that gets you started very quickly with EMF. Or if you already have an Ecore, but you have, let's say, a client that is maybe not built with Ecore, with EMF technology, and they want to consume your XML, you can create them an XML schema, and they can use that to validate with the technology of their choice. So especially if you if you are in an enterprise context where you distribute that data and you don't control the technology stack on all sides, that can be extremely useful. You don't have to force people to also use EMF. You can tell them, okay, I can give you an XML and it conforms to that XSD, and you can work with that in a way that you prefer. So in summary, this XML schema to EMF Ecore and vice versa conversion is very mature. It has a near complete coverage of all the concepts. There's a few concepts that are mapped with some complexity because Ecore and XML schema are of course a bit different and come from a bit different background. So for example, XML schema can have mixed content that can be mapped into an Ecore, but the resulting construct, which would then be a feature map, is a little bit complex in my mind. In general, it works very well. A couple of things, I can only think of one. Identity constraints cannot be mapped. This, however, is only a validation constraint, so I don't find that really a major problem. Then let's look at the second case. So now we're on the instance level. We want to take an E-object and create XML from that. That's also functionality that's right in the EMF Core. It's probably something many of you have done already. So I have some code here that creates something from the Ecore model, some user group. And then if you're familiar with EMF, you have the concept of a resource set and resources. And if you create a resource, the default resource in EMF is XML anyway. And you can just put the user group in that resource, and a resource has a save method, and thereby you store that as XML. You can also do that in memory, and you can grab just the string that comes out of that, so you don't have to write it to disk necessarily. And what I do in that test case, I save it, and then I reload that resource, and then I get a loaded user group back. And hopefully, there's a util for comparing two E-objects. Hopefully, the thing that I send out and the thing that I got back are the same thing. What are you up to? The next method, yeah? Yeah, that's correct. Yeah. Yeah. Yeah, it does work by chance because I don't really need the options. Yeah, I was playing around with UTF-8 there, so you're right. But it doesn't change anything in the demo here really. And passing in null just passes in the default options of XML, of EMF. So let's just run the test case at least once, that we can see that it actually works. And it does. So this whole EMF to XML, this is really very mature. We use it on a daily basis, also in a server client scenario. It's the default serialization for EMF. As you just pointed out, there's options you can set. If you actually pass them to the save or load method, you can influence the serialization and deserialization in different aspects. One of those aspects is also performance. So you can, with the options, make some performance trade-offs. And in my experience, the serialization and deserialization is really fast, even for large object graphs. We use it for 1 million objects and more, to an object graph with 1 million objects that we serialize and deserialize with that. So it's really super optimized already if you know which options to put in there. And if you search for that in the EMF forum, then Ed Merckx has answered that question numerous times, and you will find very good suggestions on how to optimize. Now to the little bit more difficult part. How do I get from an Ecore to a JSON schema? So we're in the upper right corner here, and we take an EMF Ecore as an input and create a JSON schema from that. This scenario is less well supported. The only way that I found to do it directly is through a workaround. There's a framework called EMF Forms. And that framework allows you to model form-based UIs, and it has a converter, or it contains a converter to also convert an Ecore. However, it doesn't allow you to do that directly, and I will just show you how it can be done for now. I have opened a feature request to change that so it can be directly invoked on the Ecore. For now, you would have to create a so-called view model project for a certain class that you would like to convert. So I'm converting a user now. And when I have that view model project, then on this file that has been generated, I have an export option to export that to JSON forms, and that creates me a JSON schema on the way as well. So what I have here is a JSON schema for the user class from that Ecore that we have just seen. There we also see a little bit of a conceptual difference in a JSON schema and an Ecore. An Ecore, in my mind, is geared towards describing a graph of E-objects that also have references among each other, where a JSON schema is really more geared towards describing one containment tree, so one root object that maybe has a couple of child objects, but they're all contained. So they don't really have that notion of a cross-reference. That's also the reason why when you export, you don't really export the entire Ecore, you export one class from that Ecore. Maybe that one class that you intend to send out over the wire. So ideally, if we go back to the slides, so this exporter is currently not feature complete. So there is a couple of features that are just not translated into the JSON schema. The tooling, as you've seen, is quite limited. Go ahead.
So not everything is exported. Is that because you haven't got around to it, or because it can't be represented in JSON schema?
Very good question, yeah. So on this slide, there's really two answers for it. So the first answer is, yes, we haven't got around to actually implementing it. So that's why I opened the feature request. So what I envision that can be done is just improve the tooling. You right-click the Ecore directly. You select to export it. Ideally, you can then export more than one E-class, right? So that you get a couple of schemata from that. But there's also some conceptual limits where the JSON schema standard doesn't really have a solution for. And two very prominent examples are cross-references. So there is a concept of something like a cross-reference, but it's not really defined semantically in the way that every validator that just understands a JSON schema would be able to understand it. So the only way I see there is you could just have just make an assumption about how those cross-references are built in your schema converter, but potentially other schema validators wouldn't be able to understand it at this point. And secondly, subclasses, it can be translated, but it looks ugly. Because the JSON schema standard doesn't have subclassing. It doesn't know inheritance. The only thing it knows is a concept that's called any of or all of. And you can then basically say, give it 3 schemata for the 3 subclasses and say, this thing that I want to have in this place is any of those 3. And then it'll try to validate against all those 3 sub-schemata, so to say. When you have a deeper inheritance tree, that starts to look ugly pretty quickly. Why that all is if you look into the history of JSON schema, it was always intended to validate a single JSON object that is sent from, let's say, a client to a server. It arrives at the server and you want to validate if it's valid with regard to a certain schema. So it was never meant that versatile as Ecore. That is, in my mind, the reason why it's limited in that way. Yeah, and then finally to the last one. So that's converting an E-object into JSON and back again. On that one, there's also a severe limitation that can be seen on the slide. Also, there's no arrow here to indicate that the JSON that was created by that actually conforms to the JSON schema. And the reason for that is that it's 2 entirely unrelated frameworks that produce the 2 things. So we have one framework that takes an Ecore and creates a JSON schema out of that, and another framework that just takes an E-object and creates a JSON string out of that, but not conforming to the same JSON schema. I'm pointing that out. It is in the use cases that I've seen, it is not really a major concern for many of the use cases. But if you have the use case where you say, I want to be able to create that JSON from EMF and then hand people a JSON schema that this JSON corresponds to, then you would have to create that JSON schema by hand at the current point in time. When we look at the demo, you will also, I think, better understand why this is the case when we look at the JSON that is actually generated by that. So in this round trip, I also have a second method, this JSON round trip. And this again works with a resource set. It uses a component EMF JSON that implements a resource where you put the E-object in the resource and you get a JSON from that. So the code looks pretty much identical. Opens a resource set, puts in the user group and saves it. This time it's a JSON resource set, which is configured below here. It needs a little bit more of a setup because it's not a default EMF framework. And then we just load the same thing again and compare the two. So that's also straightforward. And that also runs. So the code that you would have to create to actually get JSON from your E-objects is really very minimal. So it's, again, just those two methods. And then you already get JSON, and we can have a look at the JSON that was produced by that. It would look like, where is it? There we go. It would look like that, and I could format that so it would look a little bit nicer. And there you can also already see some of the things that are done by this framework. When you think about it, when it serializes out this JSON and it needs to be able to parse it back, it needs some information which E-class this maps to. So it will add some additional properties that you probably didn't intend to have to be able to do that. That's the E-class here. The rest looks pretty much like it's probably supposed to be. And that would be, for example, one of the reasons why it wouldn't validate, because it had an additional property, depending how you phrase your JSON schema. And there is a couple of other reasons if you, for example, have cross-references. So when we look at those advantages or at the facts of that is, so definitely this JSON resource is a lot less mature than the XML resource, hasn't been used that much and hasn't been around that long. And there is a couple of limitations. So the first one I've already mentioned in detail. The generated JSON does not conform to the exported JSON schema. Then when we would look at cross-references, so if your user would have a cross-reference, let's say to a task, this cross-reference handling is very EMF specific. But that's also due to the fact that JSON doesn't support that in a very generic way. So probably in a JSON message, you would just put a primary key. And that's something you can influence in the option of those resources. And finally, the serialization contains references to the E-class, at least in the default. All in all, I find that favorable over writing my own custom code to create this JSON. But that's just something to keep in mind in general. What I didn't show, but I think I have a couple of minutes left. You can also very easily get some code that actually validates something. So test case works. This is a use case, this is a test case that validates some JSON that's in some JSON schema that's in this task with E-class against some JSON. So that would be something you could typically do on the server. If you receive that JSON, you could validate that, or you could do it also in a client code. And this validates that the JSON that's in this user group conforms with the JSON schema. And I've been talking about that earlier, but I also have a test case for that. You can do the same with XSD. So you can, of course, validate your XML string against an XSD there. So in summary, EMF supports the JSON and XML serialization quite well. You can do that only on the instance level, then you don't care about the whole conversion of a JSON schema to an Ecore or an Ecore to an XML schema. You can also do it on the model or schema level and then an Ecore can be converted to a JSON schema or to an XML schema, but you cannot get back from the JSON schema to the Ecore. So if you would, for example, think about an enterprise architecture where you model your data, then maybe Ecore is a good format to start with and then to generate depending artifacts from that. The XML functionality is definitely much more mature than the JSON functionality, and all the samples that you've seen are available in this GitHub repo. I will publish the slides on the webpage of this talk, or you can just scan the QR code here. During the talk, I've also mentioned JSON forms, so I will present JSON forms as well. This is a framework that uses JSON schemas to create form-based UIs, so maybe that's of interest to you. And there's a couple of other talks on this slide that I find interesting during the conference. Particularly, I will also talk how to build web-based modeling tools tomorrow, and that will also involve in a concrete example how to use this conversion, because we will use that JSON to EMF conversion to send content between a IDE backend to a front end. And it would be great if you could evaluate that session. I think we have 3 more minutes for questions. To transform the XML that you might have stored, you can, so I don't know if it's possible, I've never seen it, but you could use EDAP to do that. That's basically what has been shown in the talk before. In my mind, that would be the best way. So if Ecore is your primary data format, you could derive that from there, and then you get a nice transformation. Yeah. And what I have seen people doing also, if what is EDAP is offering is lacking some functionality, I've seen people using EDAP to convert to a new version, and then after that apply an XSLT to do some more complicated stuff that needs to be done. But all the basic use cases are quite well supported by EDAP, and we have been using it in a couple of projects where it really worked out nicely. Okay, thank you very much. If you have any more questions, I will be at our booth, EclipseSource booth, or you just grab me after the talk. Thank you.